Hi all. So in this video we're going to see about the hematology practicals RBC count. So this is the major experiment for the university, and we'll be approaching mainly the exam oriented view. That means I've included a lot of viva questions, basic viva questions that you should know when you appear for the exam. Okay. So at first when this question is asked, you will most probably be asked to write the aim, the principle, the observation wherein you'll have to draw the squares, the steps of calculation and the result. And the question will usually be like charge the counting chambers and focus for the counting of cells. Okay, so we'll see each one by one. Aim. What is the aim of the experiment? It is to find out the number of red blood cells in 1 cubic millimeter of blood. Okay, in 1 cubic millimeter of blood. So what is the principle? The principle is the number of RBC in a known volume of diluted blood is counted, and the number of cells in 1 millimeter cube of undiluted blood is calculated from this. So we get the number of RBCs in a known volume of diluted blood, and from there we find out the number of RBCs in 1 millimeter cube of undiluted blood. Okay. So the apparatus that is used is hemocytometer. So this is the hemocytometer. See, most students when they are asked what is the instrument apparatus used for RBC counting, suddenly they might not get that term. So the term is hemocytometer. Okay, hemo means blood, cyte means cell, meter means to count, and it basically contains the improved Mbbs double counting chamber. We've got the RBC and the WBC pipette and a cover slip. Now we'll see more about this improved Mbbs double counting chamber. So see, it is basically a very solid heavy glass slide and is divided into 3 platforms by 2 deep gutters. Which are the deep gutters? See, there's a deep gutter here and there's a deep gutter here, which divides it into 3 platforms. The central narrow platform, okay, is a polished one, and it contains 2 counting areas. So see, these are the 2 counting areas which is used for counting. And on top of this we have a cover slip kept, so that we get a proper chamber or a proper volume of blood, of a diluted blood, can be used. So these are the important points to remember regarding the improved Mbbs double counting chamber. So the question that can be asked is, what are the other uses of Mbbs counting chamber? So you know that it is already used for RBC counting as well as WBC counting, but it can also be used for counting other cells like the number of cells in CSF, or it can also be used for sperm counting in cases of if whether it is low or high. You can know it by this improved Mbbs double counting chamber. And according to the specific dilutions, you can also use it for platelet counting. So these are the different uses of improved Mbbs double counting chamber. Next we will see about the counting area, more about the counting area. So see here, this is the cover slip that I talked about. Okay, this cover slip is placed just above this counting area so that you have a chamber of depth 0.1 millimeter, right? And see, this is the counting area, and here you can see that this counting area itself is divided into 9 primary squares. 9 primary squares. See, this is the 9 primary squares, and each primary square is further divided into 25 secondary square. So see, this is a primary square, this is further divided into 25 secondary squares. 25 secondary squares, and each secondary square, see, this is a secondary square, and each secondary square is further divided into 16 tertiary squares. 16 tertiary squares. Okay, so for WBC count, we were counting just the 4 secondary square, or the 4 primary square which contains the secondary square. Whereas for RBC counting, we are taking the central primary square, of which we are going to count 5 secondary squares. Okay, so for WBC, we are going to use that 4 primary squares, whereas for RBC, we are going to use the 5 secondary squares. So that is the difference in the counting area of both. So now we'll see more about the RBC pipette. So the RBC pipette is also called the Thoma glass pipette. So many students tend to forget this name. It is a Thoma glass pipette, right? So here you can see that it is a bulb pipette having a long stem. See, this is the long stem with a capillary bore and a pointed tip. Okay, and it has got a enlarged portion which is a bulb which contains a red bead inside, and there is a small rubber tube which is connected to the mouthpiece. This is called the mouthpiece. So these are the different parts of this Thoma glass pipette. So the common questions that can be asked is, how will you identify the RBC pipette? So the first point that help you to identify is obviously the color of the bead. So you can see that RBC pipette has got a red color bead, whereas WBC pipette has got a white color bead. Okay. Secondly, the markings on the pipette. So you can see that there is a 0.5 mark on both, there is a 1 mark on both, but this final marking is different. It is 101 in RBC, whereas it is just 11 in WBC. So the markings on the stem of this pipette is different. It is 101 for RBC, whereas 11 for WBC. Next is the size of the bulb. So I said there is an enlarged portion in the stem which is the bulb. The size of the bulb is smaller for WBC because only less dilution is required, whereas it is bigger for RBC because more dilution is required. So the size of the bulb is different. And finally, the mouthpiece. You can see that the color of mouthpiece in the RBC pipette it is red, whereas in WBC pipette it is white. So these are the four major differences or four major features of the pipette by which you can identify it. So the next common question will obviously be how to differentiate an RBC pipette from a WBC pipette, wherein you can utilize these 4 points itself. The next question is, what's the reason for using two separate pipettes for doing RBC and WBC pipettes? See, remember, the RBC count is around 2.5 to 5 millions per cubic millimeter, right? It's in millions. But what about the WBC? The WBC is in lakhs or thousands. It's in thousands or 10,000s. So the dilution required for RBC is much more when compared to WBC. So that is why we have to dilute it more. So we need a pipette with a bigger bulb for bigger dilution. Okay, so that is the reason for using two separate pipettes for doing RBC and WBC count. Now other questions that can be asked from this pipette is, what are the functions of the red bead inside the bulb of an RBC? See, the uses of the red bead is to, first of all, you can use it to identify whether it is an RBC or a WBC pipette. So it helps you to identify the pipette. Secondly, we can know whether it is dry or not, whether the pipette is dry or not. See, if it is not dry, which means it contains water, then your calculation can go wrong. So you need an absolutely dry pipette, and if the pipette is dry, you can see that the bead inside will be moving freely. Okay, so that is the importance of the bead, to know whether it is dry. And finally, for proper mixing of the contents, we require this bead. So that is why manufacturers have put a bead inside, so that there will be proper mixture of the blood and the diluting fluid. So these are the three important functions of the red bead inside. What are the other uses of RBC pipette other than counting RBCs? See, you can also the question can be put another way. Can an RBC pipette used for counting WBCs too? Yes, RBC pipette can be used for WBC count when it is more. When is the WBC count more? In leukemia. So in leukemias, you can use the RBC pipette to count WBC. The second function of the RBC pipette is for platelet counting. You can use it to count platelet, because platelet again is in lakhs, right? So you can use it for counting platelets. The third function is to count sperms. You can use it for sperm counting. So these are the three other uses of the RBC pipette. See, remember, whenever the count is more, you can use an RBC pipette. Whenever the count is less, you can use a WBC pipette, right? The next question that can be asked is, would not the bead decrease the dilution of the blood due to its own volume? See, the question is basically, here you've got a specific volume here, right? But won't the presence of a bead modify the volume of this compartment? See, actually the manufacturers have manufactured this in such a way that they've considered the volume of the bead too while making this. Okay, so even though the bead might decrease the total volume, manufacturers has done the corrections so that the volume is equivalent. Okay, what are the units of markings on the pipette? That is interesting. See here, they have not written any units, right? It's just 11 or 101. So what they say is basically they are just parts. Okay, they do not actually specify a unit, they are just parts in this pipette. Okay, so that is about the important viva questions about this RBC pipette, which is called the Thoma glass pipette. Please don't forget the name, it is called the Thoma glass pipette. Right, next we'll talk about the diluting fluid. So we know the diluting fluid that we have to use here is the Haems fluid, H-A-Y-E-M-S, Haems fluid. So the question that can be asked is, name the diluting fluid for RBC count, give its composition, what are the functions of the ingredients. So what is the composition of Haems fluid? Haems fluid contains sodium chloride, sodium sulfate, mercury perchloride and distilled water. So why do we need all these? See, sodium chloride and sodium sulfate together keeps the isotonicity of the fluid. See, you need the RBCs to be have a equal morphology, no unchanged morphology. So sodium chloride and sodium sulfate together will keep the isotonicity of the fluid. Sodium sulfate also prevents clumping of RBCs. So the sodium sulfate will make a uniform distribution of the RBCs so that it is easy for us to count. So sodium sulfate will prevent clumping. Mercury chloride will act as a fixative as well as a preservative. What is the difference between fixative and preservative? See, fixative means there is arrest of metabolism. Preservative means it will inhibit any growth of microbes that can contaminate the fluid. Okay, so mercury perchloride acts as a fixative as well as a preservative. And you've got distilled water 100 ml. So these are the different composition of diluting fluid, that is Haems fluid. What are they? Sodium chloride, sodium sulfate, mercury perchloride and distilled water. So what are the other fluids that can be used other than Haems fluid? Other than Haems fluid, you can use Gower's fluid, Toyson's fluid, formol citrate solution. Gower's fluid, Toyson's fluid and formol citrate solution. Formol citrate solution. Right. So thus we've completed the apparatus that is used in RBC count. Now we'll move on to the procedure. Okay, so just a quick revision of what the procedure is. We first take a small quantity of the diluting fluid in a watch glass. You prick the finger and then you take the blood up to the 0.5 mark here, right? And then you dilute the fluid up to the 101 mark. See, you take the diluting fluid up to the 101 mark, right? And then you give it a nice roll by keeping it between your palms. Okay, you roll it well so that there will be good mixing. And finally, before charging, you have to discard a few drops. So important questions that can be asked here is, what is the dilution factor? What is the dilution factor? See, we have taken blood up to the 0.5 mark, right? And you've taken diluting fluid up to the 101 mark. Okay, which means there is one part of blood in 202 parts of diluting fluid, right? Okay, so but we say that the dilution factor is just 200, not 202. Why? See, that is because even though we take blood up to 0.5 and diluting fluid up to 101 mark, the fluid inside the stem of the RBC pipette will not contain RBCs. Okay, the fluid plus the RBC plus diluting fluid is there only in the bulb. It is not there in the stem, which is one part, which means actually it is 0.5 in 100 parts of the pipette. Okay, 0.5 part of blood and 100 parts of diluting fluid. So it is 1 in 200. That is the dilution factor. So that is how you get it. Okay, so the dilution factor is 1 in 200, or it is diluted 200 times, and you know how we obtained it. Okay, the next question that can be asked is, why are we discarding our first few drops on the pipette? Why? Because the stem contains only the diluting fluid, it does not contain any RBCs. So we have to discard the first few drops, otherwise you'll have nothing to count, you'll just have the diluting fluid. Okay, so these are the important questions that can be asked from this part. Next, after that you have to charge the counting chamber, and you will charge both sides of the counting chamber. So you have to charge both sides of the counting chamber. Why? Why? Because if you don't charge both sides, what will happen to the cover slip? See, suppose these are the two counting areas and you're going to keep a cover slip like this, right? Suppose you charge just one area. What will happen? There can be an uneven distribution of cells because the cover slip will be in a slanting position. So we have to charge both sides so that the cover slip will be placed evenly on top of this, right? So, and one more thing, it is always good to take an average. Ideally, you have to take an average after counting both these counting areas. So these are two reasons why you have to charge both the areas of the counting chamber. Okay, and you have to keep the counting chamber undisturbed for 2 to 3 minutes. Why? For settling down. The RBCs need to settle down. Okay, so that is why we wait for 2 to 3 minutes, and then we have to first identify the counting area, and then under high power you're going to count the cells. So you can ask me, why not low power? You can't see cells in the low power. Of course you can see cells in the low power, but you will not be able to see it in such a way that you can count it. See, here you can actually count the number of RBCs, right? You can actually count the number of RBCs present in each square, but if it is low power you will not be able to count it clearly. So you have to count the cells in high power. Now one more point you have to remember is you're not supposed to count the both the borders. So for example, if I'm going to take this RBC or an RBC which is in the border, say suppose an RBC here, then you have to consider rule. Usually we say either you take the right or bottom or left or bottom, or remember it as you have to just take at least just two borders. Okay, so suppose this is here, this cell should go into this square. Suppose the cell is here, it should go into this square. Suppose the cell is here, it should go into this cell. So count only two borders, any two borders. You can remember it in any way. Okay, this is the L is one example, otherwise you can count it as R B. Okay, so you can count the right and the bottom margin RBC, you can remember it like that. So anyway, you have to count just two borders or cells of two borders in one square, otherwise there will be duplication of cells. That means you may count this RBC in both this square and this square. Okay, so you should have a rule for counting. So these are the questions, these are the important points to remember in the procedure. So the other viva question that can be asked is, what is the function of the cover slip? See, cover slip will provide a uniform column of diluted blood for you. Okay, so that is why we have to use a cover slip. You should not use a chipped cover slip because it will not produce a uniform one, and moreover an uneven distribution of cells will be there if the cover slip is not even. And why should both sides of the chamber be charged? I just explained that right now, because you need a even distribution of cells and a uniform column. Okay, so that's about the procedure. Next we'll move on to the calculation. So now we have charged and we have counted the number of RBCs. Okay, so now how to do the calculation? So you know that, so first of all, our principle was we have counted the number of cells in a known volume of blood. What is this known volume? We'll find it out. See, the length of one primary square is 1 millimeter. So you know that this is the primary square. The length of one primary square is 1 millimeter, right? So what about the secondary square? The length of one secondary square is 1 by 5 millimeter, because we have divided into 25 squares. So the area of one secondary square will be length into breadth, which is 1 by 25 millimeter square. Like that, we are counting 5 secondary squares, right? So the area of 5 secondary squares will be 1 by 25 into 5, okay, which is equal to 1 by 5 millimeter square. So what is the depth of this whole chamber? It is 1 by 10 millimeter, which gives you the volume of the 5 secondary squares, which is length into breadth into height, which will give you 1 by 5 into 1 by 10 into 1 by 5, which is 1 by 50 millimeters cube. Okay, this is depth and this is length into breadth, that is the area. Okay, that will give you 1 by 50 millimeter cube. So this is our known volume of blood, right? So now let the sum of RBCs in these 5 secondary squares be n, which means 1 by 50 millimeter cube of diluted blood contains n RBCs. So 1 millimeter cube of diluted blood will contain 50 n RBCs, right? So the dilution factor is 200, as I explained before. So 1 millimeter cube of undiluted blood contains 50 n into 200. 200 is the dilution factor, which will give you n into 10,000. So after counting the number of RBCs in these 5 secondary squares, if you just multiply it with 10,000, you will get the actual value. Okay. So that is the calculations. Next, very common question is what are the precautions to be taken. The precautions are, first of all, the counting chamber and the pipette should be clean and dry. There should not be any water present. The blood should come out freely without squeezing. You should not squeeze too much, otherwise what will happen? There will be clotting of blood inside the pipette due to the release of tissue factor. And while filling the pipette and charging the counting chamber, there should not be any air bubble, and the blood should be taken only up to the 0.5 mark, and the diluting fluid should be taken only up to the 101 mark. Other precautions to be taken are the blood should be properly mixed with the diluting fluid, for which you have to fold the pipette in your palm and roll it. You have to discard the first few drops before charging because it will not contain RBCs. And while charging the counting chamber, overfilling and spilling should be avoided. What will happen if you overfill or overcharge the Mbbs counting chamber? See, if you overcharge, what will happen is this fluid will go into the gutters. So your RBC count will be lesser. What if you undercharge? When you undercharge also the RBC count will be lesser, right? So that should be avoided. And the cells should be allowed to settle down and get evenly distributed without counting. And you have to prevent duplication of counting by using the rules. So these are the important precautions to be taken, right? And finally, some theory questions that can be asked from this part. You have to know about the site of formation of RBCs. You have to know everything about erythropoiesis, to be frank. You have to know about the erythropoiesis, stage of differentiation and maturation of RBCs, how is erythropoiesis regulated. And other important area that you can expect questions is anemia. Because it is an RBC count, you'll have to know the definition of anemia, types of anemia, classification, causes. You can expect theory questions from that part also. So anyway, I hope this concept is clear for you. Thank you.